Today I would like to share some experiments related to electrostatic forces. According to Google, electrostatic forces are non-contact forces. They pull or push on objects without touching them. Rubbing some materials together can result in something called charge, being moved from one surface to the other. Charged objects may pull on other uncharged objects and may either push or pull in other charged objects. In this experiment, I will gonna be showing you some experiments related on electrostatic forces and explains how they work. In the first experiment, confetti paper and combed. The atom of the paper and combed was still impact. Both materials have neutral neutrons, wherein the number of protons and electrons are equal. When the combed was ionized by rubbing it into a cotton cloth, it becomes negatively charged electrons, and those protons transfer to the cloth. When the combed was placed closely to the confetti paper without touching it, some small pieces of paper gets attracted to the combed. Is it because the confetti paper is still in neutral neutrons? As it is not charged, that is why it attracts into each other as it contains more positively charged protons than the combed. Let's have experiment 2, which is a balloon and a confetti paper. Same as what happened in experiment 1, the materials without being charged contains equal number of electrons and protons. When the balloon was rubbed using a cotton cloth, it loses protons, in accordance with the usage of triboelectric series, wherein cotton cloth attracts positively charged proton. In this experiment, the balloon becomes negatively charged electrons, and when placed closely above the confetti paper, some small pieces of paper sticks on the balloon. They get attracted as the atom of the balloon are imbalanced. It has more negatively charged electrons than positively charged protons. The attraction takes place as the paper contains neutral neutrons and has more protons compared to the balloon who loses positively charged protons. And that is how experiment 2. Let's go over in the third experiment, balloon on the wall. The atoms and the materials are still in neutral neutrons, which means they still have equal number of protons and electrons. When the balloon was ionized by rubbing it on the cloth, it loses protons as the cotton attracts positively charged protons. The balloon becomes negatively charged electrons as the number of electrons are much higher than the protons. When it placed closely on the wall, which is in neutral state, it partially sticks on the wall as the wall contains more protons than the balloon, and that is how experiment 3 works. Let's have the fourth experiment, the straw and the bottle. Both materials are still in neutral neutron state. When the straw was being ionized using a cotton cloth, it becomes negatively charged electrons as it loses protons along the process of ionization through rubbing it into the cotton cloth, for the cloth attracts protons. When placed it on the bottle, there is no repulsion nor attraction occurs, but when both hands place sideways, attraction occurs. The last experiment, roll the can. Both materials are still in neutral neutron state, but when the balloon was rubbed using a cotton cloth, it begins to ionize. The balloon loses protons as the cotton cloth attracts positively charged protons. Balloons become negatively charged electrons. The balloon is in the state of imbalanced charges, where the number of electrons is higher than the number of protons. When the balloon was placed closely to the can, it partially gets attracted to the balloon, as the can has more protons than the balloon. That is why attraction takes place.